Hi, I'm Paul Worrell. I'm the founder and chief developer of Zonafied. Today is the 2nd of July 2018 and I'm going to introduce you to this idea I've had about exploring semantic web on the blockchain. There's other people that have had a look at it some time ago, and I just took a few hours to see if I could get to the point where I could do some Sparkle queries on the Ethon model. So hopefully that's interesting for you, and well, just enjoy. It all started off when I was at DevCon 3 and I saw a presentation by Jamie Pitts on linking decentralized apps together with data, or otherwise the semantic Ethereum. Now, I had seen previously an article on Medium by a Johan Pfeffer, and so I'd seen that somebody had already been thinking about what does semantic web and ontologies mean to Ethereum. So when I saw Jamie in November last year, it resurrected all of that previous work I'd done with semantics, culminating in Sparkly Code. And of course that came to sort of an end in 2014, and I stopped that project and just made the whole thing available and didn't really promote it at all after that. But there was some amazing concepts that I discovered when I was using semantic in Sparkly Code and applying the concepts to managing software code, its dependencies, all the artifacts, the infrastructure, and the people involved with it. So I did know what the potential was with semantics. So when I saw that presentation by Jamie, it had me thinking, let's have a look at it. So this is really, you know, the journey that I've taken and where I am now. So I did have a read of a couple of papers that Jamie had referred to. It looks like the Open University in the UK has already been looking at that relationship between blockchain and semantics, and so has the University of Bonn. So so I had a look at those. There was another paper by Hector Ugart. In fact, that's probably related because it's still the University of Bonn. So I read those papers, reminded myself of what I'd done with Sparkly Code, and then I had a really good look again at what Johan had done, and I started to pick a place to start. So I looked through this article and I spotted this particular view, which is the model of a block. So I'm going to rapidly go through something that I've done to start to give me the ability to comprehend how semantics might work with the blockchain. In fact, there was no implementation of Ethon in Johan's project. So, you know, there was nothing for me to build on. So I had to find a place to start. So one was picking a place in the model, which I did. Then the second thing I did was, okay, how am I going to get at the data? And I found an interesting Medium article here by Evgeny Medvedev, exporting and analyzing Ethereum blockchain. So he's got some instructions here. All these links I'll put at the bottom, right? But he's got some instructions here on how to use some Python scripts that he's written to do an ETL to pull out of the blockchain the data effectively. He's doing it in particular with the destination of running SQL queries on it, and he's talking about how to use AWS. That's completely unnecessary for me. So all I did is on my own test server, followed the instructions, started Geth, allowed it to sync. I did run out of disk space, but I had enough space or enough data pulled out to actually explore it, which I'm going to show you. So once I'd got a sufficiently populated Geth node, I stopped Geth. I followed his instructions to clone his GitHub repository with his Python Ethereum ETL scripts in it. Okay, and then actually ran it. I ran it over a small population of the block size, you know, because I didn't have much space, and stopped there. Okay, so where did that put me? So I created a Git repo and started fleshing a few things out, and I've been checking them in. So you're free to go and have a look. So let's have a look at what I did. So first of all, I started to think about how I was going to map the data. So the data that I got from the ETL looks a little bit like this. You've got a start block and an end block, and then we've got a CSV file. So if we opened this CSV file, it might be a bit too big for me to, yeah, it's too big for me to show it to you. So in the editor here. So you just have to trust me that that data has a certain schema. So these are the schemas that I just sort of fleshed out. We're only interested at the moment for demo purposes on the block. So these are the columns and the data and the data types that the ETL provides, right? So column 1, block number, then we get the block hash, the parent hash, the nonce, etc. Okay. So the first thing I had to do, because the names of these attributes and the attributes that are available differ from the Ethon ontology. So when we look at the actual Ethon ontology here, we can see we've got a concept of a block. A block has a parent, block 2. A block can have known uncles. A block is a type of block, and a block is a subclass of uncle. So, you know, you can go and have a look at the ontology here. As I say, I'll put the notes down below. But I had to have a look at what kind of attributes existed on a block, what the relationships were to other instances of concepts, and create a mapping between the ETL output and what the ontology should be materialized like. Okay, so this is the ETL columns, as I've just said. So I then created a map. Now, the way that I used that is I just used a handlebars template. It's a JavaScript template mostly used for web development. And what we're seeing here is what's known as triples, each line representing a subject, a predicate and an object, or another way of describing that is you know, a subject, a name of a property, and the property itself. Wasn't very elegant in the way that I did this. Each triple is just explicitly defined, so there's kind of some duplication. So this is a template for one particular block record found in the ETL. Okay, so I did that mapping. Can't really explain all the details in this quick introduction, but you can see I tried to look at the ontology in Ethon and then translate the property types or the predicates across to what would be found in the input data. So here we're talking about these are sort of the placeholders. So the block number. So this is the block number, then block hash. So I'm defining the triples for the relationships between a block and a property. This here is the actual Ethon model predicate, and then these are the placeholders to replace by the columns in the mapping file. Block number, block hash, block parent hash, block nonce, etc. There are more elegant ways of putting together what's called the triples, but I just kept it simple at the moment because you can get into a lot of ugliness and confusing errors in parsing the triples. So I tried to keep it simple before I start improving it. So that is the template. I then wrote a bit of JavaScript. As I say, I'm using handlebars to process the input file and then create the records. So I'm effectively opening the file, which is the chain data. So this is the chain data. In the GitHub, I'm not actually putting the chain data in there. So if anybody wants to explore this, you'll have to be aware to produce your own data using that ETL tool and then stick it into your code repository, and then define it in here. All hard coded, it's typical ugly stuff at the moment. So I then define the mapping file, which is this handlebars template. We read the file and then we start to actually process the input stream, parse the records, and I got a function here called triplize, which takes the data and applies the template. So you can see here that it's clearly I've defined an object here which is saying which column is in which part of the data. Okay, so and I just log the result. So if it's all using Node. So if I go into scripts here, just for your information, I'm running NVM current node 950. So if I just run node on this block script, okay, you can see it's just processing that input file, applying the template, and then spooling out the records. I'm just going to do a Control C on it, cycle up a little bit until I run out of records, and then take a few of these. I know that these are the triples that have been produced by applying the template and the data. So I'm going to take, what should I do? I'll take a few of these. Let's just take, I don't know, 4 of them, he says. So he can't control his own computer. So I'll take these ones. Now, it's a bit hacky at the moment, but I've got an example TTL file here. If you're familiar with semantic web and RDF, etc., you'll notice I've already specified some prefixes in here. So I've cut and pasted the triples that are produced underneath these prefixes. So now I have some example, what's called turtle data. So now I can run some scripts just to test to see what happens. So here's some examples of some queries. Now Sparkle is the language you use to query these triples. So I'm actually using, if I show you my query script, I'm actually using ARQ, which is a utility in the Jenna, Apache Jenna semantic web sort of application framework. Okay, so you can follow the instructions on there to get hold of ARQ. right? You just install it, it'll end up being on the command line. So you can see I've just got this script, ARQ, you actually pass it some data, so I've hard coded it to pick up that example.ttl, and then I can pass in the name of a query that it will just run. Okay, so I've got a number of query for the blocks, query block stats, and just general query for all triples that exist. So if we start off with a general query, this is like the hello world query of semantics. So we're selecting all the subjects, all the predicates, all the objects, 1, 2, 3 in the triple. We're just selecting them all up to a maximum of 25. We've only got 4 records, I think, anyway, and then it'll print them on the screen. I just go into tests and I run query.sh, and I want to run the Sparkle query triples. Okay, so it's come and give us some output, and it's saying it failed to load the data, triples not terminated by dot. All right, so I hacked around a bit and I notice I've got an error here in my mapping, so it wasn't passing properly. So I'm just going to fix that problem with the appropriate way of declaring a data type in RDF here, or triples, and I'm going to regenerate everything. So I'm going into my scripts and just running the node script again, the JavaScript. All right, so just run that, boo, let it run for a bit. It'll probably run for a long time and fill my disk up. So again, just to repeat, it's processing that CSV file and then applying the template to produce triples that use the Ethon model. So I'm just going to grab a few of these triples now, paste them, stick them in my examples folder here underneath the prefixes, and move back into my test scripts and try and run that first script again. So I'm trying to run just the basic triples, which just prints out the triples crudely. Okay, there we go. Not easy to read. I haven't got time to format things nicely. But what you're seeing here is that the output of the query is the subject, the predicate, and the object. So the subject now, this here is saying IBB, which is a prefix that was declared at the top, IBB. So this is a prefix to the block number. I've decided to construct that. I've decided to use this URL. This is all part of how you express things in the data format of the semantic web. And whether this is correct or not is not the point. Whether it should be modeled or instantiated like this isn't the point at the moment. But we've got a block number. Okay, well, it's not a block number, it's an instance of a block, just happens to be expressed as the block number. Well, we've got the block creation time. Okay, there. We've then got the same block, but now we have the block hash. That's the block hash. Then we have, again, the same block, the parent block. Same block again, block extra data, the block size. Okay, and we have, see, these predicates here are actually the model predicates from the Ethon model. But this one here is actually a model predicate showed literally based on the W3C RDF schema syntax. As I had not put here a prefix for this, then it's printed out the whole underlying type reference. Okay, so I won't bother fixing that at the moment. So it's saying that the type is a block, so that's metadata. So this block has a type of block. So if we look at the Ethon model, that is a block. That's that part of the model there. Okay, and then it's pulled the block gas limit. This is the actual number of the block, which is actually an attribute on the model. Block hash number. So we can see an attribute of an instance of a block is its number. I just so happen to have used the number in, defining the unique identifier for this particular block, which obviously makes sense. Okay, then we've got all the other properties, etc. So let's just run a couple of other queries. So if we have another query, if we just look at, say, blocks. So what we'd seen there is all the triples, no matter what they were. Now I'm having a more refined query. Tests blocks. So here you go. This is a Sparkle query that's just selecting the block and its number by matching all triples that have a predicate of number as per the Ethon ontology here. Okay, so run that. Okay, so this is a bit easier to read. We've got all kinds of warnings that are coming up around types. These are to-dos now. If I go ahead and try and clean this up, there are certainly some issues with types that are defined in Ethon and how the data is actually represented. If you're familiar with Ethereum, you'll recognize the importance of prefixing the hex numbers with 0x, but it seems like semantic data types are not very forgiving on using that 0x. So I have to decide how to solve some of these problems if I decide to proceed playing around with semantic web and the blockchain. But this is the output, block and block number. We're just seeing the block and the block number, pretty obvious, okay? So let's now try block stats. So block stats, this time we're a little bit more elaborate. So we're selecting the block, the number and the parent block, and grabbing another property at the same time. So we're saying get me the block, the property number, the property block hash, and the property has parent block, and that will be an instance of the parent block. What's cool about Sparkle, you can do transitive queries. That gets kind of advanced. I'm not going to do that here, but it's one of the sort of graph resolution techniques you've got. I don't think the blockchain has, well, it doesn't, the Ethereum blockchain doesn't have a very exotic graph to traverse. It's really only the parent blocks and the uncles. But I've got this vision that if I integrate some of the smart contract concepts, we might end up with some interesting data shapes, such as I was getting with Sparkly Code. All right, so let's just run this query. Block stats. So here you can see it's saying this is a block, that's its number, and that's its parent block. So effectively on the GitHub that I've created, we've got the basic instructions where to find out how to do an ETL from your Geth node, where you'll find information about the Ethon ontology, which describes the structure of the Ethereum blockchain. Some to-dos that I'm putting on here as I'm evolving the product and thinking about other features, characteristics. So really just clone this and help me out, help me explore it and see what we can do. Cool. Thanks very much.
Whoop-de-doo! What does it all mean, Basil?